so if you see in a concave mirror, they are, see children, I'm just taking two, rays of light. In fact, there will be multiple rays. Okay, I'm just to make it clear, because if I draw all the rays, it gets confusing. If you go to page number 61, figure 5.4a, I think there are 4 rays of light out there, and it's made it pretty clear. Okay, you can see it from there only. So when rays of light in a concave mirror, okay, strikes, it reflects, right? This is reflection. They meet at a point. This is called the principal focus. And it's denoted by F. Okay, F stands for principal focus. In the book, it's also given as focal points. Just for your knowledge, so that you know all the terms. Okay. So, but usually we call it principal focus. So, if you see the rays of light are going, bouncing. So, they are meeting at a point. That is why a concave mirror is also called a converging. Okay, converge means to meet at a point. Okay, like we converge for the assembly, right? In the school assembly, when in the morning the school starts, all of us come and meet at a point, assembly ground, right? Thereafter, after the assembly is over, we diverge towards the classes, right? So converging point. Like if you are using magnifying glass also, what do you do? I don't know how many of you played with my magnifying glass. I think we used to do it when we were kids. You take the magnifying glass. Right now, I think it's not the time to do it because there's hardly any sun. But sunny days, summer months, okay, when it's really hot and there's hardly any rain, you take the magnifying glass. You can take a piece of paper or a dry leaf or anything. Okay, that is dry, not wet. And when you focus the rays of the sun, what do? You focus. You can see a point. Okay. Then all the rays are focused on that point, and the heat is also focused on that point. That's when it starts burning. Okay, I think you should play with all these things, children, because when examples are shared with you, it becomes clearer for you. Okay, if you haven't done that, you can do that. So that is what is doing. The magnifying glass is kind of converging the rays of the sun. Okay, so that's why it's also called a converging mirror. Now, it's covered out here. This side. Now, I will make a convex mirror. You can see the difference. See, basically, I'm going to tell you one more thing. Whenever you're making mirrors, whether it's concave mirror, convex mirror, or a normal mirror. Let's say this normal mirror that we use, a straight mirror, a plane mirror that we use on an everyday basis. When you do things like this, when you draw, it doesn't matter whether you draw up or down, it doesn't matter, I'm just doing it continuously. Okay, this clearly says this is the non-reflecting side, and this is the reflecting. Why these lines? Because this is silvered. This is silvered, so that this side becomes the reflecting side. This is how we show it. Okay, in whenever we talk about mirrors, any type of mirrors. Okay. So in our case out here, this is the non-reflecting side now, and this is the reflecting side. In a convex mirror, concave mirror, non-reflecting side, reflecting side. You have to be very clear about that. Okay, again then we will continue with the principal axis. Right. Now, what happens in the convex mirror is when rays of light, again I'll just make 2 rays of light. Okay. When it strikes the mirror, okay, when it strikes the convex mirror at a point, it bounces off. Okay, it bounces off. So the question might arise in this case, in a concave mirror, after reflection, after it bounces off, they are meeting at a point. But in a convex mirror, they are bouncing off. They are not meeting at any point. Okay? So what you need to do is, you need to trace. instruments, roller, anything to do. That's why I have to make it appear. Okay. Now, this is what it means. If you go by the line, that's why I told you that time you have to pay attention. The point on the principal axis where all rays of light parallel to the principal axis meet or appear to meet. This is the difference between a concave mirror and a convex mirror. Okay, in a convex mirror they actually don't meet, they bounce off, they go away. Okay, but you have to retrace it and you have to make it look like it originated from a point inside the mirror, not outside the mirror. Right? This is outside the mirror, this is inside the mirror. So that point is called the principal focus. Okay, that's what we do. That's the rule in this. Right? So this becomes principal focus and this is how it behaves. That's why a convex mirror is also called a diverging mirror. Okay, and as I told you, concave mirror is called a converging. Right now, there's no need to take notes, anything like that. You just pay attention. You are at the comfort of your house. Just relax. Don't lie down on the bed or anything like that because that will not give you any concentration. Children, that's not the way you study. Whenever these kind of classes are taking place, sit in a chair, table, or whatever. Okay, because the body posture makes a lot of difference. If lying down increased your concentration, or if lying down made you feel better, then in schools we would be putting beds rather than chairs and tables. Yeah, desks basically. Sit down properly, right? Sit down properly. Put the laptop or a phone, whatever device that you have through which you're connecting right now, in front of you, and pay attention. Just keep your mind free. Just don't get distracted. Notes are being posted. It will be posted. You just have to copy it and you have to go through it. Okay. Now, in fact, the notes were posted earlier. Some of you might have copied. It will be easier for you, right? You can keep the notes in front of you. As I teach, it will be clearer for you, right? So, this is why a concave mirror is called a converging mirror, because all the rays converge at points. And this is why a convex mirror is called a diverging mirror, because you can see the rays are going. Okay, so as I told you, you converge for the assembly, right? After the assembly is over, you diverge towards your classes, right? Okay. So, now we come to another topic called focal length. I'll have to go through the definition in the book. The distance between the pole, and this is the pole, okay, this point is called the pole, out here this point is called the pole, it's denoted by capital P. So the distance between the pole and the principal focus, is called the focal length of the spherical mirror. It is denoted by F. This is F. Okay, pole and principal focus. Okay, this is denoted by F. Okay, and there is a very important rule regarding this. Focal length of a spherical mirror, concave or convex, is always half of the radius of curvature. I told you last time what is the radius of curvature also, right? I told you what the radius of curvature. See, when you are making a circle, you take a certain radius, right, in compass. Okay, you take your ruler. Let's say in maths they tell you make a circle of 5 centimeters, right? So you take a ruler and compass, and you take 5 centimeters. You put the compass at a point and you draw a circle, right? So let's say this is the point, this is the circle that you have drawn with your compass, right? Now this is the radius. Right? Or to make it clearer for you also, this is the point, let's say this is the radius. Okay, so can you see the spherical mirror? A spherical mirror is nothing but a sphere, a glass sphere, which if you cut it, okay, and you polish it, this side concave mirror, polish it this side convex mirror. Can you see? So the radius is curvature is, if you go to the book again, It says the radius of the hollow sphere of the spherical mirror, which is the radius of the hollow sphere of which the spherical mirror is part is called the radius of curvature of the mirror. Okay, and is denoted by capital C. Right. So let's say this is the radius of curvature here, and now here is the radius of curvature. Focal point is always half of radius of curvature, and it's given in the book. F is equal to radius of curvature. I think in the book they have written is R, but okay, the book says R upon 2, since they are talking about the radius of curvature. Okay, but if you go to the topic on radius of curvature, again you can see it is denoted by R. Okay, so F by 2, or if you have to do it by R equals to. Okay, so that's the way you go about it. This is a very important formula for ray diagrams. Okay, for understanding, for later on, you might have to do calculations based on this. But we're not going to do in this chapter right now, but later on, you might have to do calculations based on this. So it's very important that you understand right now that we're talking about. Okay, so F equals to R by 2 or R equals to 2 by F. Okay. Oh, sorry. Yeah, see, I was talking about center of curvature. Radius of this radius. Okay. The C that I was talking about is what I was trying to tell you. This is center of curvature here. Center of curvature here. Okay. So radius of curvature is the radius of the hollow sphere of which the spherical mirror is part. Is called the radius of curvature of the mirror. It is denoted by R. Okay. If you go to figure 5.3b. Okay, so from here till here, here till here is the radius of curvature. So from here, and from here till here. So this is R, this is R. Right. So half of R is F, half of R is F. This is center of curvature. Right. So center of curvature is the geometrical center of the hollow sphere of which the spherical mirror is part is called as center of curvature. Okay. Now. Aperture. This term, you might, if you're into photography, this term aperture is very important because whenever you're clicking a camera and you're pressing the button, it opens for a fraction of a second. The mechanism inside, light rays enters and the aperture closes again. And that's how we capture images. Okay. So what is aperture? The area of the mirror from which reflection takes place is called this aperture. It basically denotes the size of the mirror. So small one. This is a concave mirror. This is the convex mirror. Okay, so let's go back to the book again. What does it say? The area of the mirror from which reflection takes place is called aperture. Okay, it basically denotes the size of the mirror. Sure. Now, this much of